The strange thing about fear is that sometimes it does the exact opposite of what you expect. Instead of making you run, it can make you completely still. Imagine walking alone at night when you suddenly hear footsteps behind you. You turn around. You see a shadow moving between the trees. For a fraction of a second, your entire body seems to stop. Your muscles tighten. Your breathing changes. And even though every part of you is telling you that something is wrong, you do not move. It feels like your body has failed you. But it hasn't. That sudden stillness is part of one of the oldest survival systems in the human brain. Long before humans had cities, weapons, or language, our ancestors had to respond to threats in an environment filled with predators. A dangerous animal was not always something you could outrun. Sometimes the most important thing was not to move at all. Think about a small animal hiding in grass while a predator passes nearby. Running might immediately reveal its location. Moving could attract attention. Remaining perfectly still could buy it another few seconds. And those few seconds could mean the difference between life and death. Scientists describe freezing as one part of a broader defensive system that also includes fighting, fleeing, and other forms of immobility. The brain does not simply have one emergency response called fear. It has a sequence of defensive reactions that can change depending on how close the danger is and whether escape is possible. When your brain detects a possible threat, information from your senses rapidly reaches circuits involved in detecting danger. The amygdala plays a major role in organizing defensive responses, while regions deeper in the brain, including the periaqueductal gray, help coordinate the physical reaction. And one of the first reactions can be stillness, not because your brain has forgotten what to do, but because it may be doing exactly what survival demands. For a moment, freezing can reduce unnecessary movement and allow the brain and senses to gather more information. In humans, researchers have observed threat-related reductions in body movement, sometimes accompanied by a slowing of the heart. This temporary stillness is often described as the human form of freezing. In other words, your body may be saying, "Don't decide yet. Listen, look, determine what this is." Because there is an important difference between hearing something dangerous and knowing that you are in immediate danger. A sound in the darkness could be a predator, it could be another person, or it could be a branch falling from a tree. Your brain has to make that decision incredibly quickly. And while it is deciding, movement may not always be the best option. This helps explain something many people find confusing. Why would an animal ever freeze when running seems like the obvious answer? Because escape has a cost. If the predator knows exactly where you are, running may make you easier to detect. If you are still hidden, moving could destroy your camouflage. And if the threat is very close, the window for escape may already be disappearing. So the defensive system has to adjust. When danger is distant, you may notice it and watch. When it gets closer, you may become intensely still. When escape becomes possible, you may run. And when escape fails, other defensive responses can appear. Researchers studying defensive behavior describe freezing as part of a continuum rather than an isolated reaction. As the perceived threat changes, the body can shift between different defensive states. That means freezing is not necessarily the opposite of action. It can be preparation for action. Consider a deer standing motionless after spotting a predator. From the outside, it looks as though nothing is happening. But biologically, almost everything is happening. The animal is monitoring the environment, assessing distance, and waiting for the next piece of information. Then, suddenly, the stillness disappears. It runs. Humans can experience a similar transition. A person may freeze when confronted with sudden danger and then move instantly when the brain determines that escape is possible. But there is another form of immobility that is even more extreme. It is called tonic immobility. This is not simply the brief stillness we experience when something frightens us. It is a much stronger defensive state associated with extreme or inescapable threat. In animals, tonic immobility has been observed across many species, and researchers have proposed that it can sometimes reduce the chances of continued attack. Humans can experience a related phenomenon too. In situations involving extreme threat, some people report being unable to move, speak, or resist even when they consciously want to. This is important because freezing is often misunderstood. People sometimes interpret immobility as weakness. They imagine that someone who did not run, fight, or shout must have chosen not to act. But defensive reactions are not always conscious choices. The body can enter these states automatically, and that means the person experiencing them may not have had the kind of control that an observer assumes they had. Research on human defensive reactions has documented several forms of immobility under threat, including responses associated with severe violence and trauma. There is also a remarkable connection between humans and other animals here. Across evolution, nervous systems repeatedly face the same fundamental problem. Something is coming. It may be stronger than you. It may be faster than you. You have only moments to decide what to do. And evolution did not produce one universal answer. It produced a flexible system. Sometimes the answer is run. Sometimes fight. Sometimes hide. Sometimes remain completely still. And sometimes, when there is no escape, the body enters an even more extreme state. The remarkable part is that these reactions are not signs that evolution failed to make us rational. They are evidence that survival does not always begin with conscious thought. You do not first analyze the danger, compare every possible outcome, and then instruct your heart to beat faster. Your defensive systems can begin acting before your conscious mind has fully understood what is happening. That is why fear can feel faster than thought. And perhaps that is the most surprising thing about freezing. When you freeze, your body is not necessarily giving up. It may be buying time. Time to see. Time to listen. Time to decide. And beneath the modern world of traffic lights, locked doors, phones, and electric lights, that ancient system is still inside you. The next time fear stops you in your tracks, remember what is really happening. For a moment, your body may not be choosing to do nothing. It may be carrying out one of the oldest survival strategies your species has ever possessed. Sometimes survival does not begin by running towards safety. Sometimes it begins by becoming completely still.